everyone, welcome back to my channel, and today we will together solve the daily Leetcode problem. Recently I am quite busy with the project in the company, so yeah, I have no time to share my approaches to you guys. However, like today I think that the problem is very interesting, so I think my approach is also interesting as well, because it can naturally solve this problem. Okay, let's do that. So here we can see that we have an array, and our task we can read in the description, and then we need to find the maximum sum of an array. For example, like in this case, our maximum sum of the subarray is this one. Yeah, we can find the maximum sum of subarray is this one. And yeah, so this one is what? 1 plus 2 plus minus 3 and then 4, right? So that one is 4. So that's why we have the result in here, that is the 4. And the length of this subarray we contains from 4 elements, so it means the length is 4, and it is when it get the modulo to the 2, that is equal to 0. Yeah, so that is the second conditions. Yeah, so how can we do that? So following the hint in the problem, it say that like somehow like we need to store the things like the I modulo k, and then we store all the things in some way. Okay, so let's do that. So however, like in here, if we recognize that like we always just need to maintain, for example, if this one, because we do not have the subarray of the length of 0, right? So let's say that we start from index 0, and then so it means that we increment this one by 1. So it means that this will start from index 1, and then so it means that like the length of the next one, it would be this one, right? That is the divisible for the 2. So it means that like for the next element, that would be 2. So this one is divisible for the 2. Okay, from this one, which is the next one. Okay, so that is the here, right? We have 4 elements, so on and so forth. If we start from 1, we can see that like that would be 2, and then we will go to the 4. Okay, so it means that like when we get the index, and then we get modulos to the k, and then somehow we can store them efficiently. And yeah, so let's say for example this one is the index 0, right? We will increment it by 1, and then so we have 1, that is modulos to the 2, that is the 1, right? And then so we will store these things in the HashMap. And then let's say that the HashMap with the element, because like we have only 0 and 1, right? Yeah, let's assume that. Yeah, so here, because that is the 1, so we will store it in the 1 as -5. We will store the prefix sum as suggestions from the hint. And okay, so here like this is the 2, right? Index of 1. So 2 modulus 2, that is 0. So it means that we need to add something here. And okay, so we have we will initialize our array with what? 2 divided by 2 is 0, right? And what is the prefix sum? The prefix sum is -4. That is the -5 plus 1, right? Okay, so next we will jump here, that is the index 3, and then here our prefix sum is what? Is the -5 plus 1 plus 2, so that is the -2, right? And then because like that is 3 divide, we get modulus the 2, that is the 1. So we keep adding one element here, so that is the what? So that is the -5 plus 1 plus 2, that is the minus yeah, that is the -2, right? Okay, so that is the -2. Okay, so next, so here we jump here, that is the next index of 4, and then like here we can see that 4 get modulus to the 2, we get 0, so we keep adding it here, so it means that in here we have -5. Okay, so next we do the same thing for the last element here, that is the 4, and then somehow like we can get that is the 5, right? The index of 5, 2, that is the 1, so it means that we will add it here. And then so here we sum all the things together from here, 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 and then we will have -1. Okay, so what is the meaning of these two arrays, and how can we find the maximum value? Okay, if we take a look in here, is that what is the 4 meaning? What is the -4 meaning? -4 mean that it denotes for the subarray of -5 and 1, right? This one, that is this one, right? This one. Okay, so what is the -5 meaning? -5 has no meaning for sure, I think. So here, like, so what is the -5 meaning? Okay, so -5, it means that like we can get it up to here, from here to here, right? Because in this is a special case because this one start from 0, so it means that we still have meaning of the -5. Okay, yeah, okay. So okay, so what is the meaning between the subtraction between the -5 minus 4, right? So that is the -1. What does this mean? This mean what? This mean that this is this subarray. We have -1. Okay, so it means that in here somehow we can see that. Okay, so we can see that the subtraction between any two prefix sums is indeed the array which has the length divisible to the k, right? Okay, we agree on that. So for example, so however, what is our result in this case? So our result in this case is what? So that is this array. Okay, so how can we find that? Okay, we can find that is the result between -1 minus -5. Okay, so how can we find this one? Okay, so yeah, the naive way or the brute force in here is that, okay, I will compare the gap between any two pairs, and then I will eventually find the results, right? For example, like in here, firstly, you will compare between the 5 and 2. We will compare the 5 and 2. We will check this pair, right? And then you check what? You check this pair. And then you check what? You check this pair. So you check from 1 to 2, 1 to 5, 2 to 5, right? And then so somehow like we see that, okay, the gap between the -5 minus -5, which result in 4, that is the biggest one. However, this one violates the ON. This one is the ON square. So you see, so this problem is not feasible. Okay, so how can we come up with the smarter strategy? So we can see that for any kind of the given number, let's say that if I have the 1, do I need to calculate all the pairs with respect to the number or the elements on its left? I mean the left hand side. The answer is no. And then what should we do? We only need to care the gap between the current number with respect to the smallest element. That is the smallest element on its left, right? Okay, so how can we find the smallest element? Okay, so for now, we can use the Min-Heap, right? With the Min-Heap, we always can maintain the smallest element, and we always need to compare with the top. So by comparing the current element with the top of the heap, the Min-Heap, and then we always had the biggest gap. And then what is the meaning of the biggest gap? It means that it can gives us what? It can give us the maximum of the subarray. This one will be max, right? Always. So it is like computationally efficient. Okay, so for now we can program it together. Let's say that I will use the prefix sum as the num0, and then I will initialize the HashMap to store all of the values. And then so for now I get the max value as the float number of the infinity, minus infinity. Okay, so for now we will iterate through all of the number, length of nums plus 1. So here, yeah, so I use this approach, but you still can use that kind of the index like 1 2 3 4 5 in here. So I've already code this one, so I don't want to change it to avoid the mistake. Yeah, if you want to check the submission and then like only submit it one hit and then I can got accepted directly, just me. Yeah, so from here like we are in the for loop, and then for now we check that if the I we get modulus to the k not in the hash map, it is not appeared before, and then somehow like you can get the hash map of I modulus k equal to the prefix sum, and then so in here we need to hippify the hash map of the I modulus k, and then what else, if I modulus k is already in the hash map, and then we just need to get the top of the heap, right? That would be the hash map of the I modulus k, and then we get the top element, and then we need to compare the max span between the max span and the prefix sum minus the top, right? And then we will push the element into the hash map of the I modulus k and prefix sum, right? And then for each for loop we if I equal to the length of nums, and then we break, otherwise we will get the prefix sum will be added by the nums I, and then we return the max value. Okay, so yeah, hash map typos error. Okay, so looks good. Let's see. Yeah, so I think that this is not not too difficult to understand, and I think this is the most natural way for us to solve the problem. Yeah, we define the problem by, okay, so when we classify using the hash map, we all know that we can get the maximum value by compare the gap between the two values inside the hash map for each given I modulus k, right? And then so we encounter with the ON square problem. So for this one we can solve problem using the Min-Heap, which always can give us the smallest number on the left hand side of a given number, of the current number. So yeah, so we break the problem into the smaller problems and then we solve one by one. Yeah, so this is my strategy, and I hope that this strategy is like useful for you guys. Yeah, thank you so much for watching my video, and because I am busy with my project, so I don't have enough time to do so many more videos, so I typically ignore the too difficult to go one, because it will consume a lot of time to make a video, or like the too easy one, anyone like any problem, like it just give me like interesting thing and short time to present for you guys, and we'll make the video. Yeah, I think that is my habit. I don't want to spend too much time on this. And yeah, so again, thank you so much for watching my video, and I hope that my video is helpful for you guys. If you want to give me more motivations for making more videos about sharing my interesting or like my approaches for you guys, please give me a like or comment. Yeah, again, thank you so much for watching my video, and see you next time.